Okay, folks. We got the lunch crowd. Thanks for coming in. My name is Ian Perez-Ponce. I am a member of the Storage Business Development team at AWS, covering storage and ingest services. I have my colleague here, Paul Reed, who's lead PM for Storage Gateway. And so the both of us are going to tag team a little bit and kind of walk you through deep dive on transfer services. And as we go through, we'll focus primarily on two specific areas. One, the Snow family, which is one component of our storage ingest or storage data movement service portfolio, and then we'll transition into Storage Gateway. And hopefully we'll cover some of the other elements in broad brushstrokes so you guys get a little bit of a good feel for how to move data into the cloud, as well as we'll talk about moving data out of the cloud and across the cloud. So one of the things we kind of start with in terms of a fundamental question, which is, what's driving storage relevance? I think in very generic or common workloads, we assume that storage is simply a byproduct of an application, right? Whether it's traditional back office applications, be it SAP, Oracle, et cetera, and there's some truth to that. But I think as we look at some of the more cutting-edge use cases that are dominating industry trends, if you will, whether it's artificial intelligence or the application of deep learning or machine learning, trying to actually integrate natural language processing into analytics and actually driving more application integrations that way. Internet of Things, we are at a point where we're already seeing double-digit, if not triple-digit, billions of endpoints in IoT generating everything from instrument data to just non-conventional formats, data formats, or data sources. And then we're looking at also the treatment of information as assets, right? While most companies don't put information on their financial statements in terms of the worth of that data, we are starting to see some emergence of data marketplaces where data is actually being traded and can be sold. And that kind of leads also to the last mention here, which is around data trust frameworks, whether we're looking at technologies like blockchain for basically providing scalable transparent transaction ledgers, if you will, for a multitude of use cases across verticals and industries. And so, while we look at all of these and we think, well, yeah, the application architectures that are unfolding for these are pretty interesting, one thing holds true is that storage, and specifically having unlimited storage scale to be able to work with sanitized data sets is really a foundational pillar for all of these. And so really everything is driving storage relevance. It's not just your classic applications that may have been living in the back office domain. And so based on that, we treat storage as core. Within AWS, we also see it as a foundational pillar, regardless of whether you're building cloud-native applications or perhaps migrating existing applications that might already be living on premises. We strive to provide really the most breadth of different storage services so that we can cater to everything between those two ends of the spectrum, cloud-native and traditional, let's just call it legacy applications that may already be in existence. And through that scale, really trying to get to a point where you're able to achieve more intelligent insights, or I would say actionable insights from the data as your data sets grow, obviously as your application ecosystems evolve, eventually getting to a point where you can innovate faster and apply some of these more cutting-edge trends to actually be transformational for your organization, whether that happens to be AI or ML or natural language processing, or getting to an IoT type of solution deployed at scale. So if we look at a point in time today, what is it that AWS offers from a storage services perspective? We focus in the center on core storage services. We have really three classes of storage. Object, where S3 and Glacier primarily rule. That's pretty much been 12 years in the making as far as the innovation that has been poured into the object storage class. We also have block storage offerings, Elastic Block Storage Service, which is, I would say, the equivalent to any storage, block level storage area networking technologies that some of you folks might be familiar with. And then the latest addition to the portfolio was file storage, EFS or elastic file storage, which basically complements block by providing NFS type of capable storage. So three classes. Seems rather simplistic, but each of those classes has varying levels of features and functionality. More importantly, or I should say equally important, I'll call out some of the integrations that we provide across the storage services. And so if we look to the right around data security and management, there's some core services here that are plug and playable with storage services, whether you're trying to just simply implement very granular role-based access control through something like identity access and management, or have basically auditability of what's happening across your entire storage landscape through integration with AWS CloudTrail, all the way to things like something more interesting or newer, which is Amazon Macie, which is our ML-powered, AI-powered service for actually looking through your S3 accounts and being able to identify any personally identifiable information or sensitive information that should otherwise be, safeguarded and protected. And so those are just some examples of what we provide in the operational realm for data security and management. If you look on the left, which is really the topic of today's discussion, we look at various data movement services / mechanisms, ways to get data into the platform, as well as ways to also get data out of the platform or within the platform. And so we'll cover those in a little bit more detail. I do want to reference or mention that we have a slew of customers that have led in with storage-based workloads. One of the things I'd like to call out here is that among all the storage services and features that we provide, we cater to industry disruptors such as Uber, the Ubers and Airbnbs of the world, as well as to more established enterprises, be it GE or Rio Tinto or Toyota, that are actually leveraging a wide mix, a varied mix of the storage services to actually implement various storage workloads, and we'll cover those in a little bit. But let's look at the data movement services in a little bit more detail. Basically, we categorize our data service portfolio into three pillars or three segments. One, which is network-centric. So as is implied, things like AWS Direct Connect, where you would have 10 gig or 1 gig networking from your private location or a private location, be it a colo facility or data center, to a prescribed AWS region, leveraging that bandwidth for bidirectional traffic. Pretty straightforward. There's an S3 transfer acceleration, which you can consider as WAN optimization for S3 traffic, bidirectional as well. Whether you're doing uploads to S3 or downloads to S3, you can think of that as WAN optimization for S3 storage calls. One of the newer services that we added is EFS file sync, and this is basically a utility that allows synchronization of any on-prem file or storage that you might have, specifically NFS, for instance, that you want to have synchronized into elastic file storage service on the AWS side. So giving you that sync capability without having to invest in your own tooling or third-party tooling for that matter. And then we have Amazon Kinesis Data Firehose, which is really an intelligent data shuttling service, more specifically used for moving data, let's say, from that lands in S3 to other service endpoints for being able to process or do some interesting things with that data. So that makes up the network category, and then we transition to the actual roads category, and this is where the Snow family comes in: Snowball, Snowball Edge, and Snowmobile. And so these are purpose-built appliances that we make available to customers on a pay-per-use basis. We send them to you, you fill it up with your data, you send it back to us, we import that data into your account, and then it's your prerogative what you do with that data from that point forward. And then on the hybrid side of things, we have a broad range of competent APN competency partners that play in this space, that offer everything from standalone migration solutions to mixed mode solutions that cover disaster recovery, backup, and migration. So we'll highlight a few of those in a few slides. But then we also have our own storage gateway appliance, which Paul will talk about at length, which has a couple of different modes that you can leverage to get data into the platform, regardless of what storage service you might be using on the back end, whether it's object, block, or even we'll talk about some of the file features as well, file file storage parity features that we have in play. So quite a few different options for moving data into the platform. One of the things that we like to stress is that data migration requires some fundamentals regardless of how you're looking at bringing data into the platform. One of the main things that we try to educate customers is how do you match storage to storage, right, based on what you might be implementing in an on-premises environment and where you want that storage to live once you migrate it into the cloud. And so understanding the mechanics of what of each cloud storage tier is capable of and how that services an application once it's been migrated is pretty key. Step 2 is doing some data discovery and preparation. So if you can imagine organizations that have had pretty robust storage area networks in their environment over the course of 5, 10, 15, 20 years, there's been a lot of data accumulating, and very often it's a challenge to understand what the actual composition of that data looks like as a whole before you migrate it. And so doing some discovery and preparation is actually key. The third step is data validation, right? You always want to make sure that there's some integrity checks both before you move the data as well as after you move the data so that there's no qualms about, is my data going to be of any use to me once I've moved it from point A to point B? Fourth is the transfer method selection. And as I was just walking through on the previous slide, not all methods are created equal. So there are some nuances depending on how, what method you choose to move data around. And we try to provide as much guidance as we can there. And that kind of feeds into the last step here, which is data marshaling. Depending on which specific data transfer mechanism you've chosen, it does require some conscious effort to understand how am I going to take a very large data set, partition that in a way that I can map it to, let's say if I'm using Snowball devices and you're going to wind up using 20 or 100 of them, you know exactly what that mapping looks like in terms of a portion or batch of your data set to each device. And that's just one example of many. So I spoke a little bit about the APN partners that we have in the storage domain. You're going to find, again, many players here that cross different categories, whether it's pure data migration. A lot of the consulting partners, tier 1 consulting partners obviously play in that space if you want to have the differentiated heavy lifting of migration being done by somebody else. There's many partners that play in the backup and restore space, as well as the BCDR space, business continuity and disaster recovery space, that can facilitate migrations as well. And then you have archive and primary storage partners. So just a sliver of the partners we have in this space. Certainly encourage everybody to go visit the relevant ones at the expo, if you haven't already. Okay, so now we're going to transition into focusing primarily on the Snow family. And we start by asking the question of, what is Snowball, or more importantly, why did we build Snowball? One of the things that we call out as pretty much a constant in the industry is that data bandwidth or networking bandwidth is not always accessible or sometimes attainable depending on geographic location, what part of the world you're in. Perhaps there's a cost element to it, might be too expensive. And if you're thinking about migrating large-scale data sets or workloads to the cloud, chances are you probably don't want to have a long-term contract, let's say for a 10 gig or even 40 gig pipe, knowing that you're not going to use that plumbing after the migration's complete. So we built the Snowball devices really just to provide an easy way to get bulk data into the platform without any capital outlay and without having to worry about long-term contracts with service providers for something that's effectively going to be used only once. The other element is, as we added compute capabilities to Snowball Edge specifically, we realized that in some use cases, it's not just about getting data to the cloud, it's perhaps minimizing that round trip and being able to do something intelligent with that data closest to where it's being generated. And I'll cover a couple of use cases there, but that's kind of bleeding into the realm of edge compute. And then from a logistics perspective, so prior to Snowballs, we had customers that would ship us standard hard drives, SSDs, and those are, from a logistics perspective, very error-prone. A lot of times we'd wind up getting shipments from customers that were supposed to be hard drives, but were anything but. And so we simplified that by being able to automate the shipping mechanics by including e-ink displays on the devices that automatically populate with the ship to and ship from labels. And so at a very broad view, we have really 3 distinct devices. The AWS Snowbal, which is on the left, which we introduced in 2015, comes in 50 and 80 terabyte capacities. 10 gig Ethernet networking, fully ruggedized enclosure, rain and dust resistance. It's a pretty solid box, if for no other reason, just to endure the abuse it gets of shipping it constantly around the world. In 2016, we introduced Snowball Edge. So we elevated some of the specifications there, including a 20 terabyte bump in storage. We added 25 and 40 gig Ethernet networking. And more importantly, or I should say more interestingly, we actually added the ability to run compute. And the actual first compute capability was through Greengrass. So if customers were looking to actually deploy any kind of serverless application at an edge location, they could take advantage of Greengrass with Lambda support on the device. And then it was a couple weeks ago, I guess, at the New York Summit, we introduced the ability to now run EC2 AMI instances on the device. And so this now kind of extends the capability of running compute at the edge. Again, these are primarily for use cases where it just doesn't make sense to incur that round trip of sending data all the way back to the cloud, processing it, and then bringing whatever the resulting value data set is back to the edge. And so we'll talk a little bit about that as we move forward. And then the last item here, Snowmobile, or in the last form factor, Snowmobile, basically a rig that pulls up to a data center. Usually we see these deployed for wholesale data center migrations. You're exiting a colo facility, you're shutting down an entire data center, and you just have that much data, usually in the exabyte scale, that you're trying to migrate in one operation or two. So I won't necessarily go through all the added specifications here. Here's just where we highlight a couple of the differences in the interfaces and protocols that we support across the devices, as well as some of the power differences. What I really want to call out here is just kind of the pricing structure, so there's some clarity there. Basically, for Snowball and Snowball Edge, it's a flat rate fee based on the job, and one job corresponds to one device. And then there's a daily rate accrual that accrues after basically the 10th day. So if your migration is moving a little bit slower and you figure it's going to take you 15 days or 20 days, then there's a corresponding per day price fee that you see there on the bottom. Snowmobile, on the other hand, is pretty straightforward. It's just 0.5 cents for per gigabyte provisioned. Again, if you're fully loading 100 petabytes on a single Snowmobile, you can do the math. It's pretty straightforward, and so that's Snowmobile. Some of you might be asking, well, how do I know when to use Snowball or Snowball Edge versus Snowmobile? Pretty self-explanatory. Our benchmark, if you will, for Snowmobile is anything in excess of 10 petabytes. In the same breath, I would say that we've had several customers that have actually migrated 10 petabytes or more with just Snowballs or Snowball Edges because of the feasibility. They may not necessarily have the actual space to accommodate a truck. But generally, we don't see it in the other direction. So we won't see a Snowmobile pulling up just because you have 1 petabyte or a couple hundred terabytes, which makes sense. Now, I'll highlight a couple of the key features for Snowball here. And some of these, by the way, I'll call out the ones that are applicable also to Snowball Edge. Starting with the actual S3 compatibility. So we have an S3 SDK adapter that you can use. So if you're familiar with standard S3 API calls or scripting on top of that, you can certainly leverage the S3 SDK adapter. We also have a built-in CLI that you can use for transferring data to and from the device, which is generally what most customers will use just for simplicity. Small files. When we start talking about data preparation in anticipation of a migration, Invariably, there are different file sizes and formats. Small files are generally a performance killer when you're trying to transfer at high throughput, and so we've tried to solve that problem for customers by actually aggregating or batching small files to speed up performance. We already talked a little bit about the embedded e-ink display for automated shipping label population. Along with that comes chain of custody tracking, so you always know where your device is as you order it, and more importantly, you know where your data is. And so we're pretty disciplined about making sure that chain of custody is always intact. From a compliance perspective, we have SOC, PCI, and HIPAA compliance, and this applies pretty much across the board to Snowball and Snowball Edge, and then different storage density alternatives depending on what part of the world you're in. So that's for Snowball. And then if we look at Snowball Edge, some of the key differences here is that we have an S3 compatible endpoint that's built into the device, so it's not an SDK. It's actually an endpoint that you no longer have to worry about running on a jump host or workstation. We also have NFS compatibility, so if you have, again, NFS storage on-prem or file storage on-prem that you want to actually have migrated to AWS, you can take advantage of the NFS file interface. From a throughput performance perspective, Snowball Edge is a little bit more robust. We can actually pump data at line rate, 10 gig line rate. And then from a compute perspective, focusing on some of the extended capabilities on the bottom, we have the ability to cluster devices, and we'll cover that in a little bit more depth. So if you actually need to have aggregate storage or aggregate compute or both for on-prem deployment, you can certainly cluster these devices together. I mentioned the ability to run Greengrass and Lambda, and now with the EC2 AMI support, you can run EC2 compatible instances on the device. And then lastly, the hardware encryption on Snowball Edge is unique, whereas on Snowball it is software encryption based. So just a few examples of customers that are actually using the Snow family today, and you'll notice a pretty healthy mix here across media and entertainment to folks that are more traditional in the enterprise space, mix of use cases from everything from content distribution to just traditional application migration, in many cases active archive, trying to get off of tape and ingest that into the cloud. On the partner side, we have a few partners, and the list is growing, that integrate with the device. So if you have, let's say, Commvault as an example in your environment for backup, and you want to, again, do some archive to S3 or Glacier, you can certainly take advantage of seeding those data sets through Snowball integration. But the use cases, I hit on a few of them. These are just some that you'll continue to see emphasized. There's the wholesale data migration use case. I'm getting out of the data center business or managing the data center business, and I want to move everything, and so we see that quite a bit. Backup or DR seeding is another popular one. We're starting to see a lot of database migrations, folks that are starting to get off of third-party vendors for one reason or another, and simply using Snowball to actually do that initial bulk upload. A lot of NAS archival solutions, so if, again, aging NAS filers that you might have in the data center that you want to have protected or simply just totally relocated to the cloud, see that seeding functionality taking effect over Snowball. Data lakes is an interesting one, kind of an overhyped term, but we are seeing kind of more mature deployments of data lake solutions with analytics, and so being able to actually seed a data lake with mixed data types through Snowball has been something that we've seen an uptick in. And then I mentioned active archive. I've yet to run into anybody that has an I Love Tape t-shirt, and so we do see a lot of folks just trying to get as much of that aging data that's sitting on spinning reels or tape and getting it into Glacier. Very quickly, I'm just kind of go over the mechanics. In terms of how easy is it to order Snowball, everything's driven through the AWS console or the API. You basically go to the Snowball management console. You select the job type that you want, import, export, or a cluster configuration. We basically dispatch a Snowball device. Of course, depending on the job type, we'll issue the appropriate device type, or in some cases, you can select it. Once that arrives at your location, you are responsible for basically transferring data from whatever your on-prem storage infrastructure is. You then send that device back to us. we will actually then start the ingest process into your S3 account, and that basically lands in the S3 buckets that you initially chose for the data transfer job. So we're not artificially creating new buckets for you or choosing some random bucket. This is specifically the buckets that you choose. From there, it's your choice. If you want to move the data into Glacier, or if you want to move it into EFS or Elastic Block Storage, or even use it with AWS Storage Gateway, you have that option. At that point, it's the actual data movement from that point forward is outside the scope of the Snowball service, but you certainly have that feasibility to do so. And then just to call out some nuances between Snowball version 1, what we call the regular Snowball, and Snowball Edge. As I mentioned, Snowball has the SDK as well as the client, so you have kind of two options there in terms of how to write and read data to the device. With Snowball Edge, since we run that S3 endpoint natively on the device, it's just a direct call to the device. You don't need that middle workstation that we're showing in the case of the S3 API calls on the bottom left. Okay, so now let's talk a little bit about, when is migrating data or all of your data over distance not an option, or at least not desirable. And this is where we talk a little bit about edge computing use cases, and we try to call out, where do we see these in effect? And I don't think we're at a point where we have a super well-defined sweet spot, and that's a good thing, because I think really what we're seeing is evolving use cases across a mix of verticals and industries. But I would say the common things that we see in terms of criteria where edge computing is necessary: one, data is being generated across a very decentralized topology, right? So think kind of distributed computing, but in this case, distributed data generation, and by distributed, we mean geographically distributed. The data volumes are significant, so we'll call out an example here shortly where we're dealing with customers are dealing with petabytes on a per month basis, not a per year basis. In some cases on a per week basis. And again, network connectivity is either too costly or simply unattainable based on geographic location. Right? And so just to give you a concrete example, for those of you that are kind of familiar with the development that's happening in the advanced driver application space, autonomous vehicles, every player in this space right now is suffering from what we call the data deluge problem. They've got R&D fleets of vehicles across the world that are taking numerous trips per day, generating anywhere from 5 to 10 terabytes per trip, and that's usually on the low end. And so the data is valuable. More importantly, the ability to actually process that data is valuable, but being able to send all of that data to a specific AWS region starts to kind of bring into question, is that really feasible from a cost perspective and in some cases from a technology perspective? And so what they're looking at is solutions like Snowball Edge, where they can actually provide two functions. One, collect the data as close to where it's being generated, which would mean a smart garage or maintenance facility, and then being able to process that data or do some basic manipulation of that data before they send either all or some of that data back to AWS for either archival or additional processing, whatever the case might be. And so that's just one example. I'll cover a few others. Just to give you a little bit more depth as to what we're providing with EC2 instances. So basically, this is the ability to now take C5 compatible EC2 instances and run them local on the device. We have 3 AMIs that we have made available on Marketplace, or that are already on Marketplace that we support. And you see the envelope sizes on the right, so this is a pretty good indicator of what the different sizes are that you can run, all the way from SBE1 small, 1 CPU, 1 gig of memory, all the way through SBE1 4x large, which maxes out on a per Snowball Edge basis of 16 CPU and 32 gigs of memory is the max. And then from a storage perspective, up to 1 terabyte volumes per AMI. And then you'll notice from a pricing perspective, there is kind of a change now for pricing. We realize that in contrast to using Snowball Edge for just data migration, where you're going to be using it for just a few days, at most maybe a couple weeks, if you're going to use it for ephemeral compute at the edge, chances are you might be using it for a couple months, maybe a year, maybe longer. And so we do have 1- and 3-year discounted pricing options for those use case scenarios. But what happens when one Snowball Edge isn't enough? This is where we focus on clustering. So you can have up to between 5 and 10 Snowball Edge units clustered together to give you aggregate storage and compute. You kind of see kind of the rough arithmetic there in terms of what that equates to in terms of CPU, memory, and storage. And this basically is for, again, what we would consider ephemeral compute storage for deployment at the edge, whatever the edge means to you. Presumably not a conventional data center. This is some remote location where you just don't have access to conventional rack mount infrastructure. The other thing I'll call out here is that we can actually easily swap nodes out. So if you actually want to start using some of those cluster nodes to send data back, or let's say have a separate rotation of Snowball edges coming in to actually copy data and send that back, you can certainly do that. As far as swapping nodes within the cluster, that's pretty easy. If one fails, we just ship you a new one, swap it out, send the old one back or the failed one back. As far as how EC2 instances work, pretty straightforward. Going back to the console example, you go to the AWS console, you'll select the specific compute job. You're actually going to have, or should have, an AMI image that's already created. That image will have SSH keys generated by you as the requester so that you can SSH into the device once it's powered on at your location. We then take that AMI image, provision it as an EC2 instance on the Snowball Edge. You can have up to 10 AMI images that you define. And then we just follow the same regimen as far as shipping you the device. When the device arrives, you power it up, set up your connectivity, and then basically SSH issue the standard EC2 CLI commands to power up the instance, restart it, or shut it down. But then you're using SSH to actually administer the guest OS, if you will, that's running on the instance. So the pricing's available on the public site, just like for all other services, but this just kind of gives you a quick snapshot of, again, there's a per job fee and then a daily fee that accrues depending on if you're just using the on-demand pricing. Again, if you want longer-term pricing because you're operating at scale, 1- and 3-year discounted pricing options are available. So I'll just hit on 2 additional use cases here and then hand it over to Paul. So in the healthcare, we covered a little bit around what's happening in the automotive transportation space. Healthcare is another one. Philips is a good example as far as their Health Suite platform, which powers, I think at last count, 14,000 different deployment locations, hospital systems, or hospital / medical providers that actually have medical imaging devices, anything from MRI machines to fancy, scanning, other optical scanning devices. And so what they're looking at is being able to take advantage of Snowball Edge and specifically deploying a mix of both serverless and EC2 type of applications on there so that they don't have to rely on constant connectivity back to the cloud in the event that there's some disruption or in the event that there's just not good quality bandwidth available to do that. And so if they can localize basically all operations for those medical imaging platforms, all the better for their customers, right, which are, again, the hospital staff or medical staff that are running these applications. So that's a quick example in the healthcare. In the academic research space, and I'll probably mention another one here that's somewhat similar. Oregon State University, specifically the Hatfield Marine Science Center, they have small fleet of research vessels that go out, do various mapping functions across ocean, across the different oceans, and collect various images from a coastal perspective. And the rate at which they're collecting data is probably about 60 terabytes per week. Well, actually was when we first engaged with them, probably a little bit more now. And one of the things that they were having a hard time doing is being able, at the rate that they were collecting data, being able to aggregate that and actually process it in a timely fashion, which meant shipping physical disk drives or SSDs to some remote data center, doing the processing, and that was a pretty laborious effort that they chose to avoid. And so Snowball Edge basically allowed them to minimize that expense of shuttling data around and also maintaining the infrastructure to do the processing. They were basically just doing all of that local to the vessel. You could say real time or near real time. One other, I mentioned I would just cover one other use case that is similar to operating vessels, and that's for cruise line operators. So it's a good example, again, where floor space is typically limited. Network availability, if you're thinking about satellite links from traditional cruise ship operators, not necessarily the most robust, and so the ability to actually condense their compute storage footprint, but still be able to improve the overall customer experience is key for them. And so, again, hopefully this kind of solidifies some of the different vertical/industry plays where we see, edge computing becoming not necessarily a nice to have, but really a need to have to kind of take things to the next level. So with that, I will transition to Paul, and Paul will talk about hybrid cloud storage architectures.
Thanks, Ian. I'll start off, just a show of hands has anybody tried Snowball, used Snowball? Quick show of hands. A few of you. Anybody tried Storage Gateway, used Storage Gateway? A couple of you, great. So while Snowball allows you to ship data, kind of do a lift and shift of data into the cloud, that's not always an option for some workloads. In that instance, you may want to move the storage to the cloud for a variety of reasons that Ian kind of elaborated on earlier. Maybe the cost economics or just our storage model works for you in terms of the downstream processing that you can do on it. But you still have applications that live on premises that want to be able to access that data. So that's what we think of this idea of hybrid cloud storage, where your data lives in the cloud, but you have compute or workload needs that still need access to it from your on-premises or your office environment. So Storage Gateway fills that gap, fills that void for you, where you have these ideas of things on-prem that need to get access to storage in the cloud. And Gateway bridges between your data center and the AWS data center, the AWS Cloud. What we've seen over the life of Storage Gateway, and the service was launched in 2012, is that customers will often start using the service for things like backup, DR, or archive. This is a very easy workload for most customers to adopt. It's maybe a tertiary workload for them, important, but not in the main line of their users necessarily. And it allows you to get used to the cost economics, the operational model, and sort of dip your toe in the water and get familiar with the cloud. Over the life of the service, however, what we've seen is customers are now using Storage Gateway for a much larger array of workloads. Because Storage Gateway brings data into the 3 core storage services that Ian mentioned earlier, that data is available to you using all of the capabilities that sit on top of those core storage services. And so we see customers adopting Storage Gateway as a mechanism to not just get their data into the cloud, but then allow them to move compute and move workloads into the cloud behind it. Looking at how you would deploy Storage Gateway if you wanted to try on board with the service. We flipped the diagram 90 degrees on you. Your applications live on the left-hand side here, and we provide file, block, and tape storage, and we'll talk a little about those in a moment. You deploy a VM on-prem. Now, that VM becomes your entry point to the service. VM's available for VMware, various flavors of Hyper-V, various versions of Hyper-V, and also as an AMI that you can run in EC2. The gateway connects over HTTPS, so we do encryption. It's outbound from your data center, so you can route it to a firewall, a SOC, or a proxy server, into our service endpoints in AWS. Then that service endpoint in AWS is responsible for getting the data and storing it durably in our back-end core storage services, S3, EBS, snapshots, and Amazon Glacier. As an AWS service, Ian mentioned some of the other capabilities that we have. We're integrated across sort of the maintenance, monitoring, and management services, things like CloudWatch, CloudTrail, Identity and Access Management, KMS. So you can have a consistent view or a consistent management domain, if you like, over the data that Storage Gateway is providing to you on premises, but storing in the cloud. We provide 3 types of storage that I mentioned. File storage, where your objects live in S3 buckets, and you access them as files on premises through the gateway. Block storage or volume storage, where, again, your data lives in S3 and you have full access to it on premises through the gateway. Or tape storage, where we don't just provide the storage of tapes, but we provide the device emulation that an application that wants to talk tape needs in order to read and write data, and think it's talking to a physical piece of tape infrastructure. So it becomes a drop-in replacement for physical tape infrastructure, just as the others are drop-in replacement for block storage or file storage. No matter what type of storage you're using the service for, there's sort of 4 key features that you get. One is we use standard storage protocols. So your applications that are used to talking to local storage talk to the gateway using protocols that they already understand. You don't have to modify your applications. Use NFS and SMB for file, use iSCSI for block, and iSCSI VTL for tape. The gateway keeps a local cache of data. Now, this is important because your applications and your network, as Ian pointed out, may not necessarily support your applications fetching and putting data into the cloud every time you want to read and write data. So the gateway manages a fully manages a cache on that local VM of your hot data set, the data that your applications are most frequently reading and writing. We do that, we transparently manage that for you. Your applications don't have to manage the cache, you don't have to manage the cache. We keep the data set in cache so that your applications think or see local latencies for that hot data. Meanwhile, everything is stored durably up in the cloud. So it's a cache, it's ephemeral from that standpoint. Talking about moving data, we try and as efficiently move data from that VM into the cloud as we can. So whether that's writing data up into the cloud, we do byte range puts. We compress data where we can to move it from your data center into AWS to make sure it gets stored in the cloud as quickly and as durably as possible. And on fetches, on reads, we pull data into the cache on demand as you need it. And again, we try and do that as efficiently as possible. We have some heuristics that look at your workload to try and do read ahead to get data into the cache ahead of your application. Serial reads are a very common use case of streaming a video file or doing a restore of a backup. Chances are I want to read ahead to get that data into cache to reduce the latencies that my application are going to see. Again, the point I made earlier that the gateway is really just storing data natively in our core storage services. So your storage in this instance is not on the VM. That just becomes its ephemeral cache. Your storage is actually off in the cloud in all cases. Let's look at File Gateway first. So File Gateway we introduced at reInvent in 2016 as an NFS gateway. So it provides you an NFS v3 or v4 interface for your on-premises applications with storage as objects in one of your buckets. A month or so ago, we added SMB support to that. So we had SMB v2 and v3. So it surfaces on-premises for your Windows as a UNC path or as an SMB file share. For your Linux applications as an NFS export. We give you a lot of options in order to configure how that file service that the gateway is providing to your applications is made available to your application. So, for example, if you're using SMB, we integrate with your Active Directory to allow you to restrict access to not just the share, but also the objects or the files in that share. If you're using NFS, we allow you to do IP restrictions to restrict only certain clients are able to mount that NFS mount. We support file level or object level permissioning using POSIX-style permissions. So even when somebody connects to the share, they're still bound by typical file system permissioning in order to see what they can read and write, which folders they can traverse, which objects they can read, or which files they can read. We like to do things like read-only or read-write. A lot of options on the file side to limit or restrict or manage what your file-based applications can see through the gateway. Similarly, on the S3 side, we allow you to configure a number of options around how your data lands in S3, how your data is stored in S3. You can KMS encrypt it with a KMS key of your choosing. You can select the storage class that it should be put into. We expose a variety of the S3 capabilities or features in order to do things like guessing MIME types, request to pays, controlling the ACLs on the objects that land in S3. Most importantly here with file, and a difference to our volume and tape gateways, is this is your bucket. These are objects in your bucket. So one-to-one mapping between a file that your file-based applications see and the objects that land in your bucket. You don't have to open up your bucket to a service credential. We use an IAM role that you give to the service and give the service the ability to assume that role in order to access your bucket. So you have full control over access to this data that lives in your bucket. Let's look at some of the use cases that customers use File Gateway for. So this is a common one that's come up recently with our introduction of SMB, is customers that are using SQL Server to do backups into S3. So SQL Server will write a backup to what it thinks of as a local file share on the left there. The gateway is connected to the AD domain, so you can restrict that only the SQL Server can write to that SMB file share. Data lives in the cache, so maybe your latest backup always lives in that cache. So if you're doing a restore, the data's in cache for you. Meanwhile, the gateway is going to upload that data into your S3 bucket, where you can manage it with S3 capability. So you could lifecycle it down to standard infrequent access, or lifecycle it down to Glacier after 30 days. Again, these are just objects in your S3 bucket at this point, the SQL Server backups, but they're just objects, so you can use all of the S3 capabilities natively. We have other customers that use cross-region replication to keep a second copy of that bucket, a second backup in another one of our AWS regions. We also integrate with CloudWatch events. And so you can actively make this backup part of your workload. And so after a backup completes, for example, and the data is uploaded to S3, you could spin up a workload in cloud to validate that backup is integral, or potentially even do a near-term restore into something like RDS SQL to have a hot standby in cloud based on that backup. All of this is automatable, end-to-end. You set it up and forget about it. Another use case that touches on some of the things that Ian was talking about earlier is moving data into the cloud or bootstrapping that S3 bucket using Snowball. So customer was Halliburton. They don't have the I Love Tape t-shirt. They had a whole library of tape data, GIS data, seismographic data, stuck on tapes. And when they wanted to do analysis of this data, somebody had to go find the tape, find a tape robot that was still working, put the tape in, offload the data. It took them days to get this data in order to do analysis. So what they did was they took all of those tapes, they loaded them onto a series of snowballs. Snowball shipped them into S3. They put a file gateway pointing at that S3 bucket, and now their upstream applications have access to that entire data set immediately. They have petabytes of data set in an S3 bucket, and the gateway provides a lens into that with a local cache. So as they start to want to do analysis on, say, a subset of that data gets pulled into the cache. Their analysis really works locally on that cache data. And then next week, when they decide some other region, it's JS data, some other region of the world is interesting to go do analysis on, they start to read that data from the bucket. The cache drops out the data that was used last week, and they do local analysis. So it's given them this ability to turn what was days and weeks to get access to data into effectively the data all being instantly available to them. Another use case for file gateway, again, this is another one. This is something that we see in the media and entertainment industry where they're trying to do content distribution between multiple offices. In this instance, they have two file gateways pointing at the same bucket. So one of them is writing data into the bucket, the other is reading data out of the bucket. The reason they have two file gateways is because that cache provides their Seattle and Boston office local latency to the data sets that they care about. So their applications see very quick access to the data. Meanwhile, all of their data is mastered and stored in S3. We'll quickly move on to volume gateway as another mechanism of transferring data into AWS, but it's maintaining access to it in the cloud. In this instance, the gateway provides your application block storage. That's really the volume is stored in S3, stored in AWS, and the gateway is just providing an emulation of a block device on top of that data. Because it's block storage, it's sort of opaque to you, so we store it actually in a bucket that the service manages on your behalf. It's not in one of your S3 buckets. And what this allows us to do is it allows us to be optimal with how we store it, so we do things like compression on the data, so we can optimally store it in S3, and again, that gets given back to you as a reduced cost of that storage. When you want to use that data in cloud, you can take a snapshot of the volume you have on premises that appears as an EBS snapshot, which you can then take that EBS snapshot, create an EBS volume, attach it to EC2. And we'll look at some of the scenarios that you can use to do data migration or disaster recovery in a couple of slides. The volume gateway has two distinct modes, and this kind of confuses some customers because the difference is very subtle but super important. If you're using stored mode, all of your data set is stored on-prem. So unlike the cached mode and how file gateway works, we do have a mode where effectively you can think of your cache as being 100% of your volume. This is important where you have applications that can't tolerate the latency of fetching data into the cache when they read it. Maybe they don't have a consistent working set across the volume. They need full low latency access to all of it. The other interesting thing about stored mode is you can take an existing volume that has data on it, put the gateway in front of it as an accessor to that, point your application to the gateway, and it's got access to that volume. Meanwhile, we'll bootstrap that whole volume into the cloud to give you a backup copy of it in the cloud. So you can use this as a mechanism to take an existing block device and bootstrapping it into the cloud for maybe migration or backup. In cache mode, it works very similar to the file gateway, whereby we keep a local cache of a subset of the volume. So in this instance, you can surface up to a petabyte of block storage behind a single VM, 32 terabyte volumes, with at least 150 gigabytes of local storage. So you can have a petabyte of data accessible to your applications through 150 gigabytes at least. We'd like to give you a little more. Maybe your working set is larger than that, but that's one of the minimums. I mentioned that you can create EBS snapshots from these volumes. Again, these are the on-prem volumes that are in the cloud. You can create EBS snapshots, which are fully compatible with EBS. You can also do volume cloning on the gateway, which is an interesting way of doing backup, DR, and migration. So let's look at some of the use cases for snapshots and clones here. So in this instance, I can have a gateway on premises. I can take any number of snapshots of those volumes. I can take those snapshots, and I can create another volume from a point-in-time backup of that back on the same gateway, number one here. Or I can take that snapshot and migrate it to EBS, create an EBS volume, attach it to an EC2 instance. Or in the other case where potentially I lose my primary data center, I can do disaster recovery to get a third location back on premises, back on another storage gateway. So super flexible what you can do with backups and clones of volumes. We have a customer, Stemcell, who spoke with us, spoke on stage at reInvent last year, talking about how they have adopted and are using Volume Gateway to provide them storage within their branch offices and their main office, using this snapshotting and cloning technique to give them near-term restores and a long, durable archive of point-in-time backups of a lot of their data. The third type of gateway that we have is Tape Gateway, for those who do love tape. Tape Gateway provides full tape emulation, so tape storage and device emulation. And we find, again, it's a good entree for a lot of customers, good entry point to the cloud for customers who want to make that small step of storing their data in the cloud but don't want to change their current operational processes around managing backups and managing tapes. Tape Gateway works with all of the leading backup vendors listed here. From a backup admin standpoint, you just have to use your backup application. So that integration means that that your backup application just talks to the VTL, talks to this VM as if it was a physical robot. So it becomes a drop-in replacement for the physical infrastructure. So we have a lot of customers that their initial step is to do dual backups. So they'll write to their physical robot and they'll write to the VTL. And then they realize writing to the physical robot can get dropped. And I can just write to the VTL. That local cache of data provides them that near-term restore. If that backup application chooses to eject a tape or export a tape, their equivalent of taking a tape out of their library and handing it to their offsite vendor for longer-term storage, we map that to moving the data down to Glacier. So you get that cost benefit of moving that data into Glacier. Here's sort of a schematic of that deployment, sort of bursting out, showing that it's a little more than storage here. One point I want to make here is your data is all stored in the cloud. We're not shuffling tapes between the VM and the library. This is all sub-tape level transfers that we're making. So the tapes don't live in the VM, even though we think of it as a virtual tape library. They really live off in the cloud, and really the VM is just the Tape Gateway VM is really just providing you that device emulation, that entry point into that data that's stored off in the cloud. And with that, I'd like to draw the session to a close. Thank you for coming. We've told you a little bit about some of our transfer services, Snowball and Storage Gateway, and how they fit into our overall portfolio. And I hope you guys will go home and give them a try. And if anybody has any questions, we have 7 minutes, it looks like. Happy to take questions either live here or we'll drop to the side of the stage afterwards for anybody who doesn't want to talk on mic.
Yep.
Are you familiar with like Panzura and the Sony, and how does that compare or contrast with this?
What was the second? Panzura and?
How does this compare with the Sony, Panzura,
Sure.
products such as that?
By this, I'm assuming you mean Storage Gateway?
Storage Gateway.
Yeah, so we have a broad portfolio of partner offerings in this space as well, and everybody has their sort of pros and cons. I'd love to talk to you about your specific use case, and again, I represent Storage Gateway, but I also am happy to talk about our partner solutions, and if they're a better fit for you, then that's a great option for you. That's why we have that large partner network, to fill in the broad set of capabilities that we need, or that you need, rather.
You're good? Okay. For File Gateway, how do you handle S3 eventual consistency?
So the gateway presents to the file clients a fully consistent file system. So the gateway becomes the point of, and it manages the eventual consistency on the back end on behalf of those upstream clients. So the upstream clients don't see eventual consistency; they see a fully consistent POSIX file system, and we manage the fact that the data is in S3. We manage that eventual consistency around the rules that you can reason on. It becomes an interesting challenge when you have multiple gateways pointing into that same bucket, and that's why we highly recommend against having dual writer. If you saw the scenario, the content distribution scenario, we have a reader, or multiple readers potentially in a single writer, and that avoids the problem where you have potentially two gateways or even any two S3 clients fighting against the same object. It's an area that we're looking at to allow dual writer, where the gateways may potentially talk to each other, or we could find some other way of working around the eventual consistency. And again, as we start to look at some of our partner offerings do offer that sort of multi-writable endpoint into AWS storage. So it's an area of research for us, an area of work.
Any other questions? Snowball, EC2 on Edge.
Thanks for coming. And please don't forget to submit your feedback.